Hi guys, uh, this is Sabihuddin. Now we are working on algorithms part 2. Now in this part you will observe the difference and creativity of the following as follows. That is algorithms. That means what is algorithm, what it brings to you, and what is pseudocode and why it becomes so difficult for people, those who want to write pseudocode basically, and the flow charts, and you will come to know about the flow and the same things which can be transformed from algorithms to pseudocode and pseudocode to flowchart, or from flowchart to algorithms, or algorithms to pseudocode, or from flowchart to algorithm, flowchart to pseudocode. So I'm going to demonstrate this. Keep watching. So here just I'm going to discuss basically it is known to everybody, but I'm just reminding this thing. Basically algorithm is a method, recipe, technique or procedure. As the procedure is concerned what must be done and how it should be done. Technique, basically you keep on doing some work, and by the experience you develop, you get some techniques and you learn some techniques in how to do things. And recipe means you know the step-by-step refinement or step-by-step instruction given to the computer or given to any person or anything to do the task done. So this is the basically is a combination of different methods. So this is algorithm, and I'm bringing pseudocode. Now you can see that pseudocode basically is a structured English for describing algorithms. That means you can use some constraints, you can use logical structures, you can use some expressions, and you can explain anything or express anything in a form of practical aspects. It allows the designer to focus on the logic of the algorithm without being directed or distracted by details of language syntax, and you are free to write something irrespective of that which language you choose. It is a programmer's responsibility. At the same time, the pseudocode needs to be complete, and the thing is that the entire logic of the algorithm implementation becomes possible, and you can just make a little change in the pseudocode and your original code is ready. So remote mechanical task of translating line by line into source code is very easy. So this is the job of pseudocode. What you have to do is you have to use constructs, you have to use constraints, you have to use initialization of variables, you have to use the flow, you have to use the loops, you have to use the conditional statements, you have to use everything which is a possible part of the program flow. So by using pseudocodes you can show the demonstration exactly what is going on with the program, and it is a little bit different rather than the original program which you will be writing either in a Java, either in a language, high level language or low level language is different thing, but high level language which is near to human language. So you will be writing something there, and in that way you will just transform your ideas, and something you will be changing the structure and the syntax too according to the language you learned, you have programmed for. So this is what the pseudocode is. So the next part is the flowchart. Now you can use these words while writing the pseudocode. So input for inputting values, read, opt-in, get. For outputting values, print, display, show, and for output too. And for compute, calculate, determine. And for initializing the variables and things, set and initialize, init, init. And if you want to add 1, so increment, jump, step 1, and if you want to subtract by 1, so decrement or step -1. So these are the words which can use and help ensure to write the proper and concrete pseudocode for your program. So now we are moving on to flowcharts. And one more thing you have to remember that we discussed about control structures. So all these control structures including sequence, selection and repetition will be the part of the pseudocodes and algorithms too. There are two types of flowcharts. Number one is program flowchart, and second one is system. As far as flowcharts are concerned, basically flowchart shows the flow of a program, and it keeps integration between process, decisions, messages, and the flow of program that we are to do what action and which action to be performed. So if you draw a flowchart in a proper way, so definitely, and you if able to transform that flowchart into algorithm, so this becomes a good practice for you. So what the flowchart provides you, the integration between the process box and between process, between decisions, between input and output data movement and some other decisions and the flow lines. For example, if you want to send some data from one place to other place, from one drive to other drive, from any kind of database or other things, so you can just direct the flows of the program, and you can just direct from within the programs. And if they are just going out from the program and accessing some other external entities, so this can also help you ensure to make the concurrent view of the program. So you can use flowcharts this way. So I hope you will like this. Thanks for watching.